Welcome.
Hello, everybody, and welcome to today's MIRACUM and DIFUTURE Kolloquium. We are excited to present you two presenters today. It is going to be a cooperation, shared presentation by Joshua Mandl from Harvard Medical School and from Maximilian Nussbaumer from the TUM. And I'll directly hand over to Maximilian Nussbaumer, who is going to be starting with a presentation on Smart on FHIR.
Thank you, and thank you so much for your numerous attendance. Actually, I will take this moment to introduce our guest, Josh Mandl, and he will actually start with the presentation, and also, of course, introduce myself. I'm working with the Medits in Munich for about 6 months now, and I'm happy for this opportunity to give this introduction to Smart on FHIR together with the Chief Architect of the Smart Health IT and Microsoft Health Futures Department.
Excellent. Shall we dive in on Smart?
You can just also, if you want, add some words to yourself or just dive into your topic.
Good. Well, thank you so much for the invitation to talk today. I'll say my day job is at Microsoft Research, where I work in an organization called Health Futures. And I lead a small team there that is entirely focused on healthcare data standards. So we work very closely with HL7. We help to lead some of the work groups in HL7. We are core contributors on some of the FHIR standards. And we try to make sure that not only are we writing standards, but we're also building software libraries and providing tutorials and educational materials to make it easier to work with standards. And I came to Microsoft after spending some time in the academic world. I still have an affiliation at Harvard Medical School and Boston Children's Hospital. And really the project that I'll be talking about today, the Smart on FHIR project and the CDS Hooks project, these both incubated in the academic space and now are being adopted more broadly within academic centers, but also for commercial applications. And all of the technologies that I'll talk with you today about are openly licensed and support the development of open source software on top, as well as the development of commercial software on top. So with that, let me just share a couple of words about my experience as a medical student as I was first getting introduced to this space of electronic health records. This is in 2008, 2009, 2010. I was rotating through a number of hospitals in the Boston area. I had a background in computer science, and I was looking at the EHR systems that were being installed in these hospitals, and they were very good at storing data, but they made it very difficult to reassemble the data and answer clinical questions from those data. So I spent some time on my own just digging around in these systems and trying to integrate and extract data from them. And I was lucky enough to get connected with a team at Harvard Medical School that just around that time was looking at the successful adoption of the iPhone in the consumer world. And the fact that not only had Apple created a hardware platform, but also developed a set of software interfaces, development kits, and APIs. And at the time, this was Zach Kahane and Ken Mandel. They argued in the New England Journal of Medicine in this perspective called No Small Change for the Health Information Economy. They argued that EHRs should be more like that iPhone, where third-party developers could build applications that plugged into the operating system, as it were. And if you had a better idea for a calendar management or scheduling management program, you should be able to swap in the tool of your choice. So they termed this concept substitutability. It has a lot in common with the general concept of interoperability, different systems that work together. But the goal here was at the level of the user experience, an application should be substitutable, meaning you should be able to get rid of one app and swap in a new app, and you shouldn't lose all of your data when you do that, and you shouldn't have to recreate new user accounts for everybody in your system, and you shouldn't have to begin a whole new process of regulatory compliance. The idea is that EHR should provide more of a platform capability, and these third-party apps can plug in. Now, looking back at all of this development with the hindsight of almost 15 years, I will say that a lot of the concepts here still resonate with me, but it's been interesting to see how tightly controlled the app ecosystem is on iOS in particular. Maybe the Android app ecosystem, which has developed substantially since 2010, maybe that's a slightly better example, or we could look at even more fully open platforms. But this core concept that app developers should be able to understand a user need and plug into a system without having to get permission from outside entities, just the users or just the hospital who's adopting the app, they should be able to make those decisions. I think that core idea really continues to serve us well. So we got government funding in 2010. We had 4 years of funding from the US federal government to develop this concept. And the core focus is what you see on the screen here. Many different developers should be able to write healthcare applications, and they should be able to integrate those applications with many different kinds of clinical systems. One of the main areas of focus has always been clinician-facing electronic health record systems. So how do we provide decision support? How do we make sure that apps can integrate directly into that clinical workflow? But just as important from the beginning was the use case of patient access. So how do we make sure that patients can get their data into any application that they choose to manage and make sense of it? As well as research data access. And often this takes the form of a clinical data warehouse or other research environment. We want the same kinds of applications to be able to plug in there. And we'll talk more about that concept as we get on in today's discussion. But that was the core focus. And in the middle, you have this set of API capabilities that the Smart on FHIR platform offers. So how do you make sure that apps can be authorized to see only the data they're supposed to see? How do you make sure that users can go through a single sign-on process and the apps can be embedded into the EHR system where they run? And of course, how do we make sure the apps can access data with a consistent set of data models? And for that, we use the FHIR APIs. So that's the sort of big picture. And it's worth saying that the pace of technology progress here is tightly coupled to the pace of regulatory progress. So in the United States, for example, we've had over the last 10 years an adoption of EHR regulations where essentially any hospital or healthcare provider that wants to plug into the major government payment systems, they need to use a certified EHR. And that certification program becomes the attachment point for many interoperability capabilities. So we've worked closely with some of the individuals and leaders of those federal agencies who define the certification programs in order to advocate for the adoption of these kinds of standards. We've seen some of that happen through top-down process in the US, and that can be very powerful because it reaches a broad set of vendors. But we've also seen extremely powerful bottom-up progress, and particularly in the context of the COVID pandemic response. We saw the adoption of these FHIR data models for signed payloads to represent vaccine doses or COVID lab results. And we saw that adoption happening directly from the private sector on the basis of these community standards. And that happened much faster than any of the top-down government mandated adoptions. So I think these are both very powerful components. I'll say just a couple of words about the workflow for embedding apps into an EHR experience, so particularly for a clinician-facing interaction. We won't go into the technical details, but just briefly, we use a flow that's based on OAuth, and we have this idea that apps can be embedded into different screens of an EHR, and in this way, they can be integrated into existing menus and functionalities where a clinician might just open a certain tab of their electronic health record system, and that tab might be displaying native functionality, native views that are directly built by the EHR vendor, or it might be displaying a third-party app using this smart app launch flow. But when the app is opened inside of that context, it makes sure that there is an authenticated user session that typically happens in an automated way where users don't have to take any extra steps. And then the app gets an access token that is good just for the data that the app has been allowed to see and just for the user who is currently running the session. and the app can use that access token to query the EHR for standardized data. Importantly, the app also knows which patient record is currently open in the system. And in this way, we provide context from the EHR into the app so that it can display the right information inside of the right chart. That's the basic workflow, and we have a set of standardized profiles that build on OAuth to make that happen. I'll give you just a couple of small examples of the kinds of applications that have been built using this framework, just sharing a couple that where I've been closer to the development. This is an example that came from Boston Children's Hospital, from the cardiology department, where the pediatric cardiologists recognized that the official guidelines for managing hypertension required more than just blood pressures as inputs. In order to assess the blood pressure in a child, you need to know essentially what their raw blood pressure was in terms of millimeters of mercury, but you also need to know how tall they are, whether this is a boy or a girl, and whether their height is in a certain percentile based on their age. And taking all that information together, you can determine whether the blood pressure is high or low. And typically, an EHR might store every one of those pieces of input information, but the EHR developers might not provide the clinical view that you really want from that cardiology perspective, which is for every historical measurement over time, how can I see where it ranks according to the percentiles for that age and height and gender? So this was one of the first apps that was a view-only app that integrated the data at the point of care, and it really made things much simpler in terms of being able to follow the guidelines. Without some kind of automated computation, clinicians were basically looking data up in multiple different tables and having to cross-reference them just to determine if the numbers were high or low for a given context. So that's one example of an early application. And another broad space that I'm particularly excited about is applications that contribute to management of chronic illness. So this is an example of an app that focuses on diabetes, but it's built by a vendor called Remedy that has different applications in different areas, including hypertension as well as diabetes. And these are apps that in many cases pull data in from different areas of the health record and can also surface decision support and guidance back to a clinician. So these are areas where we understand there's a large deficit between common clinical practice and what the clinical guidelines recommend. So oftentimes we sort of know the best way, or at least a better way, to take care of patients, but it's not always easy to implement that in clinical practice. And I think these kinds of applications that can really focus in on a particular area stand the best chance of helping clinicians to be able to follow those guidelines. So that's a quick introduction to the Smart on FHIR technology, and I'll pass over to Maximilian at this slide.
Thank you so much. So I will dive with you now into the adaptation of Smart on FHIR in Germany, but we will start with the Medizininformatik Initiative. So in fact, Smart on FHIR is or was considered already in 2021 as a possible way to authorize access requests for terminology resources. And in fact, there is also one consortium, HIMED, which is actively using Smart on FHIR. And also they're within a system which is using FHIR and OpenEHR as complementary standards. And in order to fully retrieve the potential and benefit from the principal foundations of Smart regarding substitutability, I want to dive now into the terminology that was also mentioned by Professor Prokosch in before, when he said that Smart on FHIR has not advanced too much yet within Germany. So in Germany, we have different models that kind of overlap with the definition of the term EHR that we have also heard now quite often within the last few slides. So when we look overseas, the US has actually defined very clearly what they mean with EHR access. And as Josh has elaborated, everyone who wants to get access to the public payment systems, they need to follow the 21st Century Cures Act. And that means to implement Smart on FHIR. And in Germany, we have this kind of difficult wall of different actors within our healthcare system, and also different laws. This list that you can see here is not everything, right? We have 16 states in Germany, and they also do have separate laws that affect healthcare. So in order to map in order to also understand what is going on the US market and how the European and the German market can also advance in this direction, this terminology needs to be mapped. However, some have already tried to do this and done it also successfully or quite successfully. Apart from HIMAT, there is also in Berlin, the Charité that's using the integration hub or created the integration hub for using smart on FHIR applications. And on the repository, there is also an example plugin for Keycloak, which needs to be, of course, be used together with an existing implementation of Keycloak. And they also provided an example smart on FHIR app. Then there are partners of Medizin Informatik Initiative that use smart on FHIR. And in fact, the example that was mentioned by Josh just a few slides ago with the blood pressure, it was already presented in the MIRACUM, the DIFUTURE Kolloquium, which I have found out by Johannes Kast 2 years ago, I think. But it was the version 1, so it was not the exactly same thing. Now Josh presented version 2. However, also Synke OS GmbH collaborates with Medizin Informatik Initiative, as far as I know, and also with NUM, with Netzwerk Universitätsmedizin, as part of the Radiological Cooperative Network. And they also use smart on FHIR. And finally, a public actor, Thematic, who got contracted from Germany to specify ISIC Connect to build and provide this module. It also builds on top of smart on FHIR. But apart from it, we have no significant market of smart apps in Germany, since there are a lot of terminologies that are yet to be defined by law. And of course, without the regulatory pressure, there is no need and no motivation often to innovate. And this slows the market a little bit. When we look at Germany and the United States on Simplifier, which is a public repository for FHIR projects, interestingly, we see that Germany has way more resources defined and also more projects going on. That's kind of interesting because it does not reflect the reality of the healthcare market. FHIR is used a lot, yes, but the progress is still, as we have mentioned, not as advanced as in the United States. And at some point, you can even say it's not helpful to have more and more data models. At some point, you can even say we have enough now because otherwise there would be a redundancy. And one way to overcome this and to collaborate and align profiles and projects is smart on FHIR, which also in the US made it possible for the Argonaut project to be established, which was also quite successful. And now I will pass on to Josh again, who will tell you something about clinical decision hooks, which can be used in scientific environments.
Yes, so the concept that I'll just briefly introduce here is a learning health system where you have a positive feedback loop that includes the collection of data, the advancing the understanding of science based on analysis and experiments, and then returning what you've learned in the scientific endeavor back into the clinical workflow. And using this kind of framework, I just want to point out a couple of points in these numbered arrows here, where smart on FHIR and some of the related specifications have a real role to play. So one is at the point here, this label number 2 around assembling data. There's a strong and important capability to instrument an EHR system with access to standardized data profiles. And in the US, we've really focused on, as Maximilian says, a relatively small set of profiles that we consider core data elements. And so by putting a lot of the community's energy into working with a relatively small set of profiles, I think we get some more leverage out of those profiles. But this includes things like medications, problems, allergies, lab results, immunizations, and very, very importantly, the full set of clinical notes. And so all of that comes down to being able to pull data out of the EHR where it can be used in the context of advancing scientific understanding. But then the other arc that I think is really important to talk about is sort of 7 and 8 here, which comes back to how do you apply your knowledge at the point of care. And so one thing you can do is to take a research result and kind of embody it in a Smart on FHIR app. So maybe you've come up with a risk score, or maybe you've come up with a disease model that's going to help clinicians make better care decisions. You can build an app around that, and we've seen some really strong examples of open source apps being used to disseminate research results in that context. So that's one very clear piece of this picture. The other that I want to just briefly mention is you could imagine a world where there's so many apps that are very focused and do one small job, and the apps might individually do a very good job, but it might become quite taxing for a clinician to know which app they should be running on which patient. And to the extent that that becomes a barrier to adoption, we also have parallel work on a project called Clinical Decision Support Hooks. And the idea here is to be able to proactively surface recommendations inside of the EHR workflow at the specific points in the workflow where they will be the most relevant. And those recommendations can include a suggestion to launch a specific app right at this point in the workflow. So this is a set of specifications that we began developing at Boston Children's Hospital, and it's now been standardized through HL7. And the basic idea here is, you might have many different points in the clinical workflow that are what we consider to be hooks for the introduction of decision support. And so when the clinician takes a step like beginning to enter a medication order into the EHR, that might trigger a notification using CDS hooks to a set of external services. Those services might review the prescription that's being written, as well as other contextual data about this patient. They can leverage their own underlying knowledge base, as well as the FHIR data associated with the EHR. And by applying that knowledge to the in-context information, they can return a set of cards that would be displayed to the user. And those cards can include just simple information like text that says, by the way, this medication might cost $200 a month. That's what we call an information card. It might include a suggestion that's tied directly to a change. So maybe there's a button that says to switch to a generic medication, and that button can be instrumented in the EHR. So it takes the effect that's described in terms of FHIR resources. Or it could be a suggestion to run an app. So maybe there's an app that's specifically tailored to managing hypertension that would be applicable for this patient. And so the card could include a link to directly launch that app in the context of this patient. And so these clinical decision support hooks are another really important piece of the story for instrumenting the clinical workflow in a standardized way to support the learning health system model. And I just wanted to put that out there because I think smart apps alone are important, but they still leave some major questions in terms of the user experience. So that's CDS hooks. And then at the end of this deck, we've just included a set of links to some of the specifications and some of the content that we've talked through. So that's all of the formally prepared material, but I think we'd be very happy to answer questions or entertain follow-up discussion.
Okay, thank you very much, Maximilian and Josh, for your nice presentation and giving us this great overview about the background of Smart on FHIR and about different application pilots, and especially the addition with the hooks at the end showed us how to integrate it in complex workflows. Thanks a lot. Are there any questions? Martin. Dein Ton ist, glaube ich, aus.
Könnt ihr mich jetzt hören?
Yes.
Thank you very much, Josh and Max. Very impressive, especially from a point of view in Germany. For us, this is kind of a dream, we can say. And so my question is always, at which point in time in history and did you manage to bring the government to put so much pressure on the industry, and by which decision was that achieved, that they really did such a good rational choice and really enforce the interoperability you have now achieved? I think I've just had a look to EPIC or some other producers of large health systems, and they all have their FHIR implementations open available. And so how was this achieved, and at which point in time? Probably it was 20 years back or something.
Yeah, so it's a very complex area, and I think there are more challenges than I've highlighted here, but I'll mention a few. It's not all working perfectly, and there are places where we've simply been lucky, or there have been a lot of accidents along the way. I mean, maybe the near-term stimulus for a lot of this was in the Great Recession. Much of the funding that came out of that recession, so 2008, 2009, the U.S. had a lot of stimulus funding for the economy, and one way to inject stimulus funding was into the healthcare system, and so there was a very strong push to adopt electronic health records, even at a time before most of these interoperability capabilities, existed. So the U.S. government spent a lot of time and sort of focused attention just stimulating adoption, and at the same time, this was maybe a 5-year period. They were attempting to ramp up the certification requirements so that the systems that were being adopted were actually enabling these capabilities that were policy, that were important strategic priorities for policy. But through all that, so maybe the federal government spent $35 billion incentivizing the adoption of EHRs, and then they spent $15 million supporting the research project that became the Smart on FHIR effort. So very, very significant funding for a research project, but also not even a rounding error in terms of the overall investment in EHR adoption. But that was one that I think had a pretty strong impact. The other piece of the story is that it's iterative. So at each stage, we've had 3 sets of rules that have come out to define the incentive programs. And then we've had a series of 3 or 4 follow-ups that define the certification programs that expand over time. And when things are working at their best, we look and see what worked and what failed in the last round of rules, and then introduce corrections or try to close gaps. So from an app developer's perspective, it's been possible to write apps using Smart on FHIR now for 5 or 6 years against some of the biggest EHRs. But there's a long tail of EHR systems. We have hundreds of certified EHRs. They do not all do as good a job as EPIC. EPIC has one of the better FHIR implementations, in part because they're a large company and they have a lot of engineers who think carefully about this, in part because I think they are the most threatened by antitrust considerations. They really need to be doing a good job and be seen to be doing a good job of enabling interoperable access. So all these things play together, and it takes a sustained effort. It's not that any one point in time was the critical juncture, but it's to say, year over year, we're going to keep improving on these programs. I think that's the real recipe for success.
Yeah, thank you. And so industry has seen also the chance in taking the standard earnest and not seeing the challenge or like it as something which would decrease their effort, their how do you see?
Yeah, their differentiation. Different vendors have taken very different approaches. So early on, Cerner, back in 2013, 2014, they saw this as a competitive advantage to say, we're going to have the best support for these standards. And they launched a set of marketing campaigns and technical infrastructure. And that was very powerful in convincing some customers to use their system. Other vendors have been dragged along. We've certainly seen examples where vendors have released APIs that are technically compliant, but these vendors don't really want their customers to use them. They would rather if their customers used proprietary APIs. So there's a whole mixture. I think the most important thing is to make sure that it's working in the places that see the value, and then take the lessons learned from those places and bring everyone else along through that experience.
I have two questions which are closely related to each other. Let's start with the first question about the user experience. Isn't it a little bit confusing maybe for a typical clinical user when one opens from old-fashioned EHR environment and user interface all of a sudden an app, and it has a completely different interface and lookout? And if you have a second app which again looks completely different, doesn't this get confusing to users sometimes? What is your feedback to this?
Yeah, I think it can be. This is a real consideration, and it's important. I will say that early on we had a lot of discussion about some aspects of this, like the look and feel and sort of the human interface guidelines for these applications. And we even developed some areas of the specification to provide more consistency there. So we allowed the EHR to sort of provide roughly a style sheet that apps could use in order to integrate more closely with the look and feel of the host system. And the truth is that in real world experience, nobody adopted those particular capabilities. Maybe just because we didn't do a very good job of defining them, or maybe because it's not as big an issue in practice. It's not clear, but there is always this tension between how much do you allow folks to sort of innovate and explore new pathways, and how much do you try to provide consistency? I think one of the better answers here is, we do start to see suites of applications that are developed by one organization, and at least for that suite of applications, they have a more consistent look and feel across them. And at the end of the day, I still do look to the mobile app ecosystems as a kind of analogy here. And it's very possible for Android applications to follow Google's style guidelines and achieve a fair amount of consistency, but it's up to the app developer. I use some apps that totally go off and do their own thing. And like for example, I have an application on my Android phone that the app basically reverse engineered the data protocol for this Abbott CGM sensor. And for me, it's a much better app than the first party app to read data from my continuous glucose monitoring. But the user interface is crazy. It was just developed by one guy. It has its own UI paradigms, just totally bespoke. But sometimes the value proposition is still there.
Okay, and a second question related to this, on the other side, if the user experience was very nice and happy with all those new apps, didn't they tend then to claim to their own EHR provider, why do we need you at all if all your functions are not good enough for us, so that we have to fill up your EHR with hundreds of other apps? And didn't they then tend to throw out the existing EHR systems because it was easier to move them out?
So I think it is fair to say that one of the goals of enabling third-party applications is to lower the switching costs between EHRs. And that is even, in many cases, there's a stated policy priority. So for example, in the US, we have a requirement that every EHR needs to be able to do a complete data export on the whole population. And the goal there is to make sure that providers are not locked into the systems. So in part, I think you can make this case. But I would say there's maybe two other things I would look at here. One is, on the other side, you might say, well, the EHR developers one of the best ways they can tell which functionality is important for them to build is to go and look and see what apps have been successful. And they can look and see, oh, all of our customers are really enjoying this app. We can build that into the EHR, and it'll be even better integrated with our existing systems, and it could have some real advantages. So we certainly see dynamics like that, which can challenge or can threaten app adoption. But the other side to this is that even if much of the user's time is spent with a third-party app, the EHR is still responsible for a core set of capabilities around the secure and private management of data. So even if it was just a set of core platform capabilities, it's still doing something important that you wouldn't want each app to need to take on its own. So I don't know. I generally don't make predictions about sort of what will happen over time here, but I think we see some of both sides of this. We see more functionality being pulled into the EHR. We also see more time being spent in apps, and both of those things move in tandem.
Okay, thank you very much. So we have another question from Katja Hoffmann, please.
Yeah, can you hear me?
Yes.
Yes. My question is regarding open source components for smart on FHIR infrastructure, like the Keycloak extension and the IBM FHIR server developed by Lee. For example, what's your opinion on this? Is it a good idea to develop open source for critical infrastructure or not?
I mean, my personal opinion is that I love to see open source options for all this infrastructure. I think it's a very important sign of a healthy ecosystem that anybody can deploy a compliant instance without a lot of permission from the outside world and without a lot of reliance on vendors in terms of turning services on. So I think that's really important. In the practical sort of reality of deploying applications, it can be hard to bring a totally open source project up to date with the specifications and keep it alive and keep it well managed over time, that sort of maintenance burden. It's very hard to do those things if there's not some company or set of participants who are leveraging these technologies in a commercial way. Like something needs to be driving income for the people or the organizations that are maintaining the tools. And so that story can be a little easier to tell in an ecosystem where there's just one vendor and they're providing services and they're also maintaining open source tools. That's sort of the simplest, most compact graph of participants. With the Linux for Health server, which was previously the IBM server, I think this tells an important cautionary tale. Like, it was wonderful that IBM invested in this open source tooling. It's still really excellent software, but it turned out not to be something that they could maintain as a long-term investment in that way. And they wound up essentially sort of donating the code to the Linux for Health, to the foundation. So we see a few different patterns here.
Yeah. Thank you. Another question. Do you know another open source components or infrastructure?
So there's, in terms of Smart on FHIR and FHIR core infrastructure capabilities, the set of Happy libraries and the Happy server is maintained primarily by Smile. Smile also offers a set of commercial products that are sort of built on that same base. So they have a clinical data repository, which is a commercial CDR, but also, very strong open source components. So that's one example there. The team that builds AidBox also has a commercial FHIR server and some open source components. Microsoft has an open source FHIR server, which also makes the basis of the FHIR server for Azure. So that same code base is sort of used in both of those ways. But I can't point to an open source project that really has contributions from like multiple commercial stakeholders who are really contributing to the same code base in a very strong way. I think that is harder to organize.
Thank you.
Okay, thank you very much. So thanks, Max and Josh, for your very nice presentation again, and everybody for questioning and discussion. While we are moving now to the evening of this day, Josh, you will just start in an exciting day for the US. So we wish you good luck and a peaceful day, at least today and tomorrow and the following.
Thank you. I'm afraid that we may need it, but I really appreciate the opportunity to talk with you, and don't hesitate to reach out for any follow-up.
Okay, thanks a lot. So
Okay.
I will just mention that on next Tuesday, we'll also have a joint presentation again from Frankfurt and from Greifswald, and we'll see a presentation about ProSkype, a tool to manage data usage applications. So see you in a week. Goodbye.
Goodbye.
Goodbye.